In our previous problems, we have solved for each of the three components in the percent equation. Here's the percent equation, and we have solved for each of these. I'd like to show you an interesting manipulation of the percent equation, and we're going to look at this from another perspective. Suppose we actually solve this percent equation for percent. That is, we isolate the word percent on the left side of the equation. Now, to do that, we would want to get rid of the base. And to get rid of the base, we simply divide on both sides by base. So we show this side and divide by base. We show this side, divide by base. Now, as expected, the bases would cancel. We'd be left with percent is equal to amount over base. Just another way to set up the percent equation, you see. Now, the percent is some number like, 20%. And you know we can take a percent and we can write the number over 100. Percent means per 100, and we saw that we could think of this as 20 over 100. So writing it like this, we create a situation where we have a proportion, and this is called the proportion method of solving percent equations. Now, the number up here would be the digits involved in the percent. Now, we're going to just call this percent over 100. But it's the digits involved in the percent without the percent symbol, and the 100 is down here is to take care of that percent symbol. So that's how we'll use this. Let's take a problem or two and we'll see what I mean. We have 15% of what base is 7. Now, the whole trick here is to write this proportion and then fill into the proportion. And I think the challenging part, if there is a challenging part, is to identify amount and base. It's real easy to pick off the percent. It's the item that says percent, or it's an item with the percent symbol in it. But the other two numbers, the amount and the base, are a little bit more difficult to see. Now, if we have the problem written like this, it's important to realize that we have percent of some amount here, I shouldn't say amount, percent of some quantity, and that quantity is always the base. And is some verb form, and on the other side of the verb there is a single amount, and this is the amount. So amount, base. Base is next to percent like this. All right, so amount over base, that's 7 over an unknown quantity, which we're calling n. Now, when I say percent here, I'm just talking about the digits involved, and so that would be the 15 over 100 is the way we set up our proportion. And now we cross-multiply to solve, as we know from our previous work. 15 times n going this way first, 15 times n, 15n, and multiplying this way, it's 100 times 7, or 700. Then we show the division of 15 on both sides to find n to be 46 2/3. All right, the challenging part, the part that I really want to emphasize here, is the part where we write down our proportion, and then we fill into the proportion. I'm pretty confident that we can solve from there. But it's percent over 100 equals amount over base. Now, it is the case that percent of something, you see, will appear in our statement, and that something is going to be the base. And the number that's isolated on the other side of the verb is the amount. So here we're looking for the amount. Now, let's fill in. The percent number is 20, so it's 20 over 100 equals amount, the isolated part, if you will, what, that's n, over base. It's a percent of the base, so the base here is 50. And now we cross-multiply. If we want to assure ourselves that the letter is on the left side, then we just involve the letter in whatever cross-multiplication is necessary. 100 times n is 100n. By the way, I'm not suggesting that the letter has to be on the left side. It's just that it's a little more customary to do it that way, but it's not necessary. And in the other direction, 20 times 50 is actually 1,000. Then we divide on both sides by 100. And we want to be sure to show that division. Hundreds go out as expected. We find n to be 10. n is 10. Here we're looking for the percent. What percent of 85 is 17? Once again, we write the proportion, and now we kind of fill into it. Now, percent is what we're looking for, so the letter will go here. So it's n over 100. And notice when we find n, we're really finding the digits involved in the percent that we're looking for. The 100 is kind of the replacement for the percent symbol here. Now, let's see. For amount and base, we have percent of some quantity. Oh, this quantity must be the base. The part that's the number that's isolated on the other side of the verb is the amount. So 17 is the amount. The base is 85, and away we go. Cross multiplying, going this way, n times 85 is 85n. Going the other way, 17 times 100 is 1700. Dividing on both sides by 85. The 85s go out on the left as expected, and we find n to be 20 when we perform the division. Now, an n of 20, remember n was the numerator here of this fraction. So this is 20 over 100, and the percent then that we're looking for is 20%. A calculator can be purchased for $28.50. This amount is 40% of the cost of the calculator 8 years ago. What was the cost of the calculator 8 years ago? In solving a word problem like this, it's important to write a sentence in the percent, amount, and base format. That is, we know that amount is some percent of base. Well, how do we write that as a sentence in this problem? It turns out that the second sentence lends itself well to that idea. It says this amount. Now, this amount refers to the previous sentence, so a calculator can be purchased for $28.50. It's this amount means the cost now. So the cost now is 40% of the cost 8 years ago. And now we go through the process of identifying amount and base. The percent is pretty easy. And here the amount is 40% of the base. More generally, we talked about the amount being some percent of the base. And even more general than that, it's the idea that a part is some percent of a whole. Part is percent of whole. And the part number, incidentally, will always be smaller than the number for the whole as long as the percent is less than 100%. So anyway, this is just the basic idea of how this sentence is structured. And it's important to write the sentence before we begin to solve the problem, because then the solution becomes rather easy. Here we set up our proportion. The percent we know to be 40. The amount is the cost now, and that cost now is $28.50. So we write in 28.50. The base is what we're looking for, n. Now we'll solve by cross multiplication. Multiplying along this diagonal, we have 40 times n, so we'll write 40n. Bring down the equal sign. Then along the other diagonal, it's 100 times 28.50. And when we multiply on the right, we get 2850. Then we'll divide on both sides by 40. After the cancellation on the left, we bring down the n, and on the right, when we divide, we find the answer to be 71.25. That's $71.25. Now, that is our answer, and we could write our answer at this point. But I would like to go back a bit and show you how to solve the problem using just the percent equation, something that we did in previous sections. I think it's important for us to know that we can solve this problem in two ways. The cost now, well, the cost now is 28.50, 28.50, you see. The word is means equals. The 40% we write as 40 hundredths. The word of means times. And then the cost 8 years ago is what we're looking for, so we'll let a letter stand in for that. See, a direct interpretation is what we were doing when we were solving problems like this earlier. And now we'll go through the solution. The math manipulation of it is to divide on both sides by 40 hundredths. And when we divide on the left, we find the answer to be 71.25 as expected. The answer then is the cost of the calculator 8 years ago was $71.25.